Good morning, everyone. My name is Aidan Finn, and welcome to this presentation on a blueprint for a cloud reference architecture. I am Aidan Finn, as I said, and I'm a principal consultant working for Innofactor Norway. I am a Microsoft Most Valuable Professional, have been for 12 years, and my current expertise is Microsoft Azure. In the past, I have been a System Center Configuration Manager and a Hyper-V or Windows Server Cloud Data Center Management MVP. And I have 20 plus years working as either a consultant, an engineer, technical author and blogger, trainer, and so on. You can find me on aidan.fin at innofactor.com, and you can learn more about us on www.innofactor.com. And as you might tell by my accent, I am not Norwegian, I am actually Irish, and I am based in the Midlands of Ireland working for Innofactor Norway. So, when we talk about the cloud, there are typically a number of challenges with the cloud. And the information I'm showing here is information that EY shared in their Norwegian Cloud Maturity Survey for 2019. They've been running this survey now for a number of years. And although this information is about Norway, I'm sure if we ran this survey in any of the countries in Western Europe, we'd actually see the same results. Owners of businesses, CTOs, CIOs, IT managers, security officers, all have the same fears about the cloud. We start off with the typical things, like lack of experience or lack of skills with the cloud, complexity in moving legacy applications to the cloud. And those are things that we can help out with. We have lots of those skills that we can offer to our customers. But you got other things like fear about how to do security, because this is a whole new platform. How do we do security in the cloud? How do we manage that? Are we able to trust that environment? How do we deal with regulatory compliance? How do we deal with things like PCI DSS and GDPR? A big worry for the owners of the business is the cloud cost. The cloud is based on a consumption-based model. The more you use, the more you pay. And it's a very agile environment that enables self-service. And that makes people scared that their developers and operators are going to go crazy deploying, big expensive systems. And then at the end of the month, you're going to get this big whopping bill, and it's going to be damaging to the business. That could be scary. Identity and role-based access control and complexity of managing these many systems all make people scared of the cloud. And that causes a number of different things. It might be that the business delays their adoption of the cloud, and that actually damages the business, makes them less competitive, especially if their competitors are adopting the cloud. But it drives one of two approaches that we see people using for adopting the cloud. The first, and a very common one, is a large enterprise signs their enterprise agreement with Microsoft or starts a CSP subscription or whatever it is, and they dip their toe into the water to see if it's too cold or too hot. They deploy a point solution. So their developers, their operators get together, they start a project, and they build some line of business application, something very small typically, and they deploy that into the cloud to see how it goes. And that's done without the oversight of security officers, central IT, all the people who know how to do your classic compliance and security operations. And then another one of those projects starts, and then another one, and then another one. And they're all individual point solutions. There's no integration, there's no big picture thinking. And while it's very agile, it's very flexible, it's very difficult to support because there's no centralized management, there's no standardization, and the wrong people are doing security. So now it's your developers and your operators, not your security experts who are implementing this security. In fact, they might not be implementing security at all. And if they are, it's being done in all different kinds of ways that probably aren't being tested the right way, that aren't being designed the right way, and might not be meeting the company requirements or regulatory requirements or industrial standard requirements. The alternative, you see, is where IT lead the charge in adopting the cloud. They deploy a big centrally managed network. And this is trying to be all things to all people. So now we've got the right people doing security. We've got the right people doing compliance and oversight. However, this goes one of two directions. This is a very locked down environment. IT like to do that. But then we sacrifice that agility that we expect from the cloud. Now your developers and operators don't want to use it. The alternative is IT create this very loose environment. And that's as bad as the first scenario that we talked about with the point solutions, because now your developers and operators will just put things wherever they think is best or wherever it just works. So we've seen situations where business or developers and operators are putting up business systems with sensitive data in front of the firewall on the internet. So what we need is something that gives us the flexibility and agility that the cloud can offer, but with the security, the governance, and the compliance that the business requires. Now, these businesses who do adopt the cloud typically then engage a company like us and say, hey, we've started using Microsoft Azure or whatever it is, and we need governance. And we've done that. And what we found is it doesn't work. It's too late. The systems are already there. The bad processes are already there. The bad names are already there, and we can't change them. And it's very difficult to get the necessary people to buy into the process of introducing governance at this time. We find that we can conduct countless workshops and do that over a year, multiple years, and in the end, it's a waste of your time, it's a waste of your money, and you're not getting what you actually needed in the first place. So we need a different approach. And to find that different approach, we've stepped back in time. We've looked at how we've done security and governance in the past, in the classic physical data center. That classical physical data center, it's a physical building, concrete and steel. And at its heart is a network core. And here you'll find core switches, firewalls, and routers that are responsible for connecting that physical data center to the outside world. That data center doesn't trust the outside world. So all connectivity, whether it's from on-premises, the internet, partners, vendors, suppliers, customers, must go through that network core and pass through that firewall in that network core. Then we deploy our services into virtual networks around the data center. So whether you're doing virtual LANs or you're deploying VXLAN for software-defined networking, we're going to use that generic term of virtual networks. And those applications communicate with the outside world through that core. They do not have direct connectivity to the internet. And over time, we deploy more and more of these applications in more virtual networks. All of these virtual networks are cabled back to that core switch or core switch stack in that network core. And they connect to each other through that network core. Now, ideally, they'll go through that firewall, but what you typically find in an enterprise is people said, that was a bit too difficult, so we just let those virtual LANs talk to each other. They'll only go through that firewall if they're going to a secure network like a DMZ or if they're going to the internet. That physical data center has a fixed amount of capacity. So when we get to a certain point, we have to build another data center. So a very expensive project will start to build additional capacity in another physical building. And if we need to put services closer to the customer, then we build another expensive physical data center in a location close to the customer. Those data centers are very well run. The operations manager is responsible for running and writing and evolving an operations manual. That operations manual describes everything that can be done in that data center. Who can do it, when they can do it, how they do it. What process must they do before they even implement a change? And what is the process for rolling back from that change if things don't go right? It describes the security of an environment, both physical and network, and possibly even at the application layer. And importantly, budget is typically managed by that operations manager too. So they will understand who is the customer, whether they're internal or external, of each of the services deployed in that data center, and they can implement chargeback for those services. This is governance. This is the holy grail of what we've been asking for in the cloud. And we have used those patterns and those concepts to design the Innofactor virtual data center. We've been inspired by the past. What we've done is taken those patterns, those concepts of a physical data center, and we've re-implemented them using platform features of the cloud to enable us to create a governed and secure virtual data center. Now, this means we're deploying things like naming standards, security. We're standardizing the deployment using infrastructure as code, and I'll talk more about that later. Everything's monitored. We've cost management designed into the solution. It's not an add-on. We've role-based access control designed into the solution. It's not an add-on. We've so much more as well, which we'll talk about here. Everything is built on this scaffold or foundation. So we start off by building the model, the architecture, using management groups in Microsoft Azure. This allows us to model how the business will be administered or controlled. So we model how we're going to deploy policy to the environment to control what can be done, who they can do, or who can do it, and how they can do it, and also the role-based access control. So what people will be able to do things in that environment, and what level of access will they have. We also deploy a number of central services, and those are deployed into some subscriptions. So we have a dedicated governance subscription where we deploy some resources and services for overseeing the environment and controlling the environment. And we have some central management features as well, which we'll talk about a little later. An important aspect of this design is that every service is deployed into its own dedicated subscription. Now, some people will question that and say, that sounds a bit complex. It sounds like we're going to have a lot of subscriptions. If you think about subscriptions as just being a logical construct, we're actually just using a different logical construct than what you would have in the past, which is something called a resource group. You can think of that as a folder. This is just a higher level of folder if you want to think of it in an abstract way. It's also following Microsoft's best practice. So if you talk to the Microsoft Azure product group, they will tell you one service per subscription is the best way to scale out a large environment. So if you want to deploy policy, role-based access control, have all your quota dedicated to a single service, standardize your deployments, and have built-in natural boundaries for your cost management, then you'll implement this approach. This is a simplified view of the network architecture of this Innofactor virtual data center. And we'll talk a little bit about the components in here. First off, we have the hub. And this is the network core of our virtual data center. Then we have the spokes. These are the virtual networks where we deploy the services of the virtual data center. Now you might say, hey, I thought I saw a lot of virtual networks in there. It sounds like you're going to be doing something that's very virtual machine focused. And we keep hearing from our techies and from consultants and from Microsoft that we should do as much digital transformation as possible and use the platform features of Azure, so the PaaS elements of Azure as much as possible. And we wholeheartedly agree. It's part of our assessment process when we do an Azure migration. We try to get as much transformation done as possible to limit the number of virtual machines you will actually deploy in Microsoft Azure. However, Microsoft have realized that while PaaS is fantastic, traditional PaaS deployments haven't been great for security and regulatory control and governance. What we need is to connect those services to the network to be able to guarantee the security, the privacy, the control that you require. We have a number of ways of doing that in the virtual data center. So we're leveraging service endpoints. We've designed around a new preview feature called private link or private endpoints. We have support for a large number of PaaS features such as App Service Environment, Logic Apps, Azure Kubernetes Service, Azure SQL Managed Instance, and so on and so forth that connect directly into that virtual network and get private IP addresses on that virtual network, allowing us to control data that can go in and data that can go out. Plus, we've designed some flexibility to deal with certain scenarios that don't necessarily suit a data center deployment. Another thing you might say is, we saw a firewall in there. Does that firewall have intrusion detection? Does it have IPS and IDS and all these other TLAs? And the answer is, well, actually, in Microsoft Azure, pretty much none of the virtual appliances actually have any of that stuff. So what we do is we decentralize those important features. Instead of running them at one point, that an attacker could easily bypass, we're running them across the entire environment. So yes, we do have a network firewall. And yes, we do have web application firewalls for modern applications that are run on HTTP and HTTPS, but we also do security throughout the entire environment. Every subnet has network security groups. That's layer 4 or transport layer firewalling. We add on top of that a feature called traffic analytics, which logs, classifies, and helps us filter the traffic that's passing through a subnet. So we can use that to report on any traffic flows, whether they're malicious or benign, and whether they've been allowed or denied, and what their sources and destinations are. Even tell us what countries they're coming from. We have Security Center, which is where we're using machine learning to identify patterns of attacks across the environment, whether that's on the network or even in the guest OS of virtual machines. For example, it can identify compromised machines where the attacker is now Bitcoin mining and costing us money. Plus, we have Azure Sentinel, which is Microsoft's SIEM solution. We'll talk more about that security information and event management solution in a little bit. The virtual data center has been designed to be mission critical. So we deploy the highest levels of high availability and redundancy within this hub. So we have redundant resources. We have resources that are designed to deploy across what are referred to as availability zones, so independent physical data centers within that Azure location or region. We deploy that where it's available in that region. And the virtual data center is designed to not rely on the outside world. So it doesn't use resources from the outside world to survive. In fact, it doesn't even trust the outside world. It doesn't trust the internet. It doesn't trust on-premises networks. It doesn't even trust other virtual data centers that you might deploy. So you don't have to deploy just one virtual data center. You could actually deploy many virtual data centers. And we do that by controlling the entry and exit points, just like you would in a classic physical data center. So the first of these is site-to-site networking, where we connect your on-premises network to the virtual data center. And we can do that in a number of ways, including ExpressRoute or WAN connectivity and site-to-site VPN. And we also support software-defined WAN using Microsoft's Azure WAN solution. And now we have traffic flowing across these private connections. From there, we can route traffic in one of two directions. The first is we go through an internal WAF. So now we're inspecting the traffic for a HTTP or HTTPS application that's hosted in the VDC or virtual data center. And we're doing that inspection at the layer 4 or transport layer and layer 7 or the application layer using the OWASP 3.0 rule set. So we're looking for things like SQL injections and malformed HTTP requests and so on. We also can route legacy applications. So non-HTTP, non-HTTPS applications through a firewall, and then forward those requests, if they're allowed, to the back end. So we're filtering, we're inspecting, we're classifying, and logging that data at that firewall. We can publish legacy services to the internet using DNAT rules. So internet clients could connect to some legacy service that isn't HTTP or HTTPS through that firewall using up to 100 public IP addresses and connect to those services that are hosted in those back-end spokes. But if we're talking about modern applications, so HTTP, HTTPS applications, we would publish those through a public WAF. So we're deliberately separating an internal WAF from a public WAF for scalability reasons, but also to isolate the compromises that might happen from the internet. So if there was a DDoS attack against this environment, if it was successful, it might swamp that public WAF, but it would not have any impact on internal traffic to the internal WAF. Again, this WAF is doing layer 4 inspection, transport layer, and layer 7, application layer using OWASP 3.0 for our HTTP, HTTPS applications that are hosted in this backend. We understand that attacks happen. That's just the reality of IT. We can do our best, and things will still happen. And what we need to do is isolate those zones that an attacker can get into. Now, we know plenty about what are of examples where this has happened. WannaCry a few years ago hit many organizations, including a few headliners in Norway. And then we also see things like this bottom headline where it says Russian hackers now go from foothold, so from entry to your network, to full-on breach, full control within 19 minutes. A year ago, that was 24 hours. So these people are getting better and better at attacking us. So what we've implemented is a secure zone concept, where we limit the trust and connectivity between services within the virtual data center. So the services do not trust the internet. They do not trust on-premises networks. They do not trust virtual data centers, and they do not trust other other services in the same virtual data center. So if you look on the right-hand side, you'll see we have 3 different services running in this virtual data center. And you can see the flows of traffic. So within a service, we are not routing through the hub, but we are still inspecting, filtering, and classifying the data using the network security groups. However, if a service wants to go from one service to another, that traffic must go through one of 2 paths through the hub. For legacy applications and services, it will go through the firewall, where it will be filtered, logged, classified, and either denied or allowed. If it's a modern application, it'll be treated just like an internal client coming across that site-to-site VPN or express route. It will route to the hub, go through the WAF, the internal WAF, where that application is published, and then route back to that other service where that web application is hosted. Just like a physical data center, a virtual data center has a fixed capacity. So we're able to do approximately 450 applications within a single virtual data center, or line of business applications or services. And when we start to fill up a virtual data center, we can very quickly and very economically deploy an additional virtual data center. And if we need to put services closer to the customer, well, we have a few options where we can simulate that connectivity. But if we need to put services physically closer to the customer, we can use one of the other Azure regions to deploy additional virtual data centers. And each of these virtual data centers will route to each other directly across the second largest private WAN on the planet, which is Microsoft's global network. An important part of what we're talking about is infrastructure as code. Infrastructure as code gives us the standardization and so much more. So we build governance into the DNA of the virtual data center. It's not something we bolt on afterwards. The naming standard is built into the code. We deliver a naming standard that we have built, we have tested, we have stressed at scale. We get fast deployment. We're not sitting there clicking at a UI. We deploy our infrastructure as code solution in a matter of hours. This allows us to standardize our builds, but importantly, down the road, allows you to standardize your service builds in that environment too. And we're able to enforce best practices. So for example, in virtual machines, we deploy the best types of disks that are supported and offer the most functionality and services. This is how we build a virtual data center. We've built a library, or written a library, of modules that deploy resources in Microsoft Azure. And this is our Innofactor infrastructure as code library, and it's our intellectual property. When we're deploying a solution, we can pull some of those modules and combine them with per deployment or per client customizations or parameters. When we combine those modules and parameters together, we build resources. And we can structure those modules together to create solutions, such as the virtual data center. And this is not programming. So you might hear the phrase infrastructure as code and think that is programming. It's not. I certainly had that reaction a few years ago when I first heard the term, and I was wrong. These modules are written using JavaScript object notation, or JSON. This isn't a programming language, it's a description. It's a description of the result, not the process. Now, what skills do you need for this? Well, you have to understand the syntax of JSON. You need to use some tools such as Azure DevOps or Git. You need to use Visual Studio Code. You need some scripting such as PowerShell or Azure CLI. And of course, you need to be able to understand what you want delivered. So that means you have to understand Microsoft Azure. We use infrastructure as code to deliver the VDC, but then we continue to use infrastructure as code to deliver the services in the virtual data center. This means that you are able to continue that self-service deployment concept using a higher level of standard. You're able to build in the governance, the security, the naming standards, the controls, the best practices into your service deployments, meaning that your developers and your operators are now delivering a higher standard of deployment that your IT can support, that you'll easily be able to document, you'll be easily able to manage, and you'll be easily able to secure and guarantee that you're doing things the right way to secure that company, which leads us to governance. We need to adopt governance and we need to adopt this virtual data center. And one of the big fears of the cloud has been skills and knowledge and security, which stop adoption, which then harm the business. So part of what we do is we deliver a dedicated governance subscription. The first thing you will find in there is documentation of the governance. So that data center manual will be implemented as a virtual data center manual. It describes the governance to run the virtual data center and the technical documentation that describes the deployment of your virtual data center or your virtual data centers. And the second thing we deliver is a service called the Innofactor Virtual Data Center Concierge. And this is intellectual property of Innofactor that we have developed. And it's a service that has an API interface, and I'll describe why we have an API interface in a second, that allows you to trigger or schedule particular tasks. So if you want to deploy a brand new service in your virtual data center, we have an API to trigger the deployment of that service. So that deploys the subscription in your enterprise agreement, and it deploys the environment that your developers and operators will be able to use to start deploying their resources into. We have automated tagging of new resources. So tagging is an important function in a governed environment in Microsoft Azure. So we can add information to each resource. For example, we can automatically, at the time of deployment, tag your virtual machines, your web apps, your Azure SQL databases, whatever they are, with the name of the person who deployed that resource and the time and date that they deployed that resource. Information that's actually very difficult to find in Microsoft Azure. We can automatically manage the power state of your virtual machines. So if you're in a dev environment, we'll do that automatically for you. We'll shut down those dev machines every night. But we can use tags to identify when our production virtual machines should be shut down and started up, if they're only used on an infrequent basis. And we can also gather additional reporting data. Now, we gather lots of data in the virtual data center for monitoring and reporting, but some information is not gathered because it's more logical. So we can add that logical information to our resources and then gather that to change how we view our report data, which brings us to management and reporting. We're delivering configuration management, monitoring and reporting, audit logging, SIEM, and cost management as a part of the virtual data center. So configuration management, what is that? Well, this is where we're going to do things with our virtual machines. So we're going to do update management for Windows and Linux. We'll configure our deployment schedules, and we can either do static deployment schedules or we can base that using resource information to identify when those machines should be patched and rebooted. We implement change control, so we identify what changes are made and when they're changed, very useful in supporting and troubleshooting issues. And inventory management to identify what resources are actually deployed out there. Everything in the virtual data center is monitored automatically, and I mean everything. This is part of the infrastructure as code. We enable all of the monitoring. So the health data, diagnostics data for troubleshooting, performance data, security data, all sent back to one central repository, which we can then use in a delegated manner to our resources. So developers and operators who don't have that central access will still be able to see all that data for their resources through their resources that they do have access to. But central IT management, security officers will be able to view that data in one of a number of different ways. We have a number of dashboards that we deliver as part of the virtual data center. This is an overview dashboard of a single virtual data center, giving us a bit of information about the firewalls, the express route connections, the site-to-site VPNs, the traffic analytics for our network security groups, so the security implemented at the subnet level, shortcuts to critical resources in the hub, and information about our system updates, our change tracking, our backups, and service mapping to identify how our individual machines, if we're using virtual machines, how they connect to other parts of the virtual data center, Azure, and the internet. We have a dashboard for the firewall, so we can very quickly see the health of the firewall and the security of the firewall. We're able to dive deeper into our network security group flow analytics, so we can identify threats on our subnets and patterns of behavior and top talkers on our subnets. We can dive into individual services. So this is actually a pair of domain controllers running as virtual machines in a virtual data center. And we can see their CPU, their memory, their traffic data, their backup data, and their storage information. We have central monitoring of all the backup of all of our databases and virtual machines and our storage accounts. We also have audit logging. Everything you do is logged in Microsoft Azure. We take that data and we store that in two different ways. The first is we put that into a log analytics workspace where we can query that. And that's kind of our short-term retention, our operational database. So it's very easy to query and do visualizations on. But for legal retention reasons, we can store that data for many years. And you say how many years you want, whether it's 5, 10, 7, 11, or infinite. We can store that in tiered, economic, read-only storage. And after that predefined period, we will automatically delete that audit data from that storage account on a day-to-day basis. And that actually ends up being very economic storage. It works out at about 1.5 cents per terabyte of data. We also are implementing, as of now, because it's just generally available, Azure Sentinel, which is Microsoft Security Information and Event Management, or SIEM solution. So this takes all of our monitoring signals, puts them into one place, and then analyzes that data for security patterns, behaviors, and trends. We can also connect this to external sources, so it doesn't have to be just Microsoft Azure. This can include on-premises devices, such as your firewalls, your syslogs, and even external clouds, such as AWS or Microsoft Office. And of course, we have cost management. Because of the decision to deploy services on a per subscription basis, we have a natural boundary for cost management. Every subscription is its own bill. That's how Microsoft do the billing. So when we look at the cost management of an individual subscription, we are actually looking at the budgeting, the cost management, the projection of costs for that service, that budget, that cost center. Everything in that subscription is associated with that cost center. This makes it very easy to understand how much an individual service costs. So how does all this fit into our bigger Innofactor picture? Well, we're building a solution that balances control and agility. We have the control that IT require, that security require, that the business requires, the shareholders require, the legal industrial requirements require. We have that fixed network core where we're controlling all inbound and outbound flows. It is the only interface to the virtual data center. And here, the right people have access to do the important tasks. We balance that with the agility. So services are deployed into dedicated subscriptions and environments, which we refer to as spokes. Here, developers and operators are free to do their work, so they have fewer restrictions than they would have in that big centralized environment. And they are able to operate within the controls that the business lays down. So they're not going to be able to connect directly to the internet, but they will go through that hub or core, just like they would have in a classic physical data center. And you can put restrictions down on how much they can spend and what sort of resources they can deploy. And this makes it an ideal environment to do agile IT, such as DevOps, which is a big trend that we see in medium to large enterprises now. The virtual data center falls into the Innofactor cloud journey. So we typically start this journey with a customer at the assessment stage, where the customer is trying to figure out how they're going to move their legacy resources and services from physical data centers up into the cloud. So we'll conduct an assessment to evaluate what's there, whether it should move to the cloud or not, and if it is moving to the cloud, what would be the best way to do it? Should it remain as virtual machines, or should we transform it into cloud native services in the platform? We can take some of that information to help us design and implement the virtual data center. Now, to deploy a virtual data center, we actually need very little information. It's mainly information about passwords, domain configurations, and how we're going to integrate this into your network. And that is actually a very simple conversation that we can have in about 10 minutes. With that information, we build the virtual data center. Now, we typically build that in our own private environment first to make sure that it is going, the customized build will be perfect when we deploy it. Then we deploy that in your environment. We deploy test subscriptions in there as well, so we can build test services and validate that environment with your IT staff if that's required. Then we document the environment, we build it up, we start migrating your services in, and we start that handover process with your IT department, your security departments. So they have the documentation, they get the training, and our consultants will work with your staff to help you start populating your virtual data center. That virtual data center is now the landing zone for the migrations that are going to be planned from the assessment. New services will also be deployed within that virtual data center. So they can be virtual machine based, or as I said, they can be platform based. And hopefully then, with the information you have about the virtual data center, the security that's implemented, the governance that's implemented, that will help you drive your adoption of the cloud inside your business and help you become more flexible, more agile, and more responsive to opportunities and threats. So what are we delivering on? If we go back to that EY survey and look at all those fears, well, we're solving the lack of cloud expertise and the complexity of migrating legacy applications because we have that experience. Using the virtual data center, we're dealing with security concerns, compliance and regulatory concerns. We're dealing with the complexity of managing those cloud costs. We have a very simple model for managing those cloud costs. People typically over-engineer managing cloud costs, trying to use resource tags, which then become a whole other system that have to be managed and maintained. We just have a very simple solution. Use the natural cost boundaries of Microsoft Azure to help you manage those cloud costs. We have a role-based access control system that is built into the design. It just deploys. You simply have to add users into the necessary groups to give them the access to those systems that you want them to have. And we have many different services here, but one centralized management solution where we're sending all that monitoring data. We make it very accessible, either through dashboards, reports through that management system, or even present that data through Power BI. So you can then publish that in your own SharePoint interface or your Teams interface or whatever it is. Now will help you drive your performance and help you in that migration from CapEx to OpEx. So what's our call to action? What would we like you to do? Well, if you're going to Microsoft Ignite and you'd like to talk more about this, contact my colleague, Eric Monson, at eric.monson@innofactor.com and have a chat about meeting up with us. We're going to have, I think, about 12 people there, and we'll be happy to talk to you about the virtual data center and other services that Innofactor can offer. If you have an account manager with Innofactor, have a chat with them about virtual data center, security, and compliance and governance in the cloud. If you don't have an account manager with us, give Eric a shout, eric.monson@innofactor.com, and he'll be glad to have a chat and arrange some conversations. Number 3, begin your agile but governed future today. Adopt that virtual data center. Talk to us. We'll help you start driving the adoption of the cloud in your environment.